For f of x equals 3x minus 4, what is the new function g of x resulting from a vertical shrink by a scale factor of 1/2? So for a vertical shrink, you're multiplying the outputs by 1/2. So your g of x is going to be 1/2 times f of x, which is the outputs of the function f of x. Okay, so basically, g of x is going to be 1/2 times this 3x minus 4. And you could leave it like this, or you could distribute. I'll go ahead and distribute just so you can see what that looks like. So 1/2 times 3x is 3/2 x, and then 1/2 times negative 4 is negative 2. Okay, so the function could be written this way as well. And now we're going to graph them and compare. So first of all, f of x, which is going to be y equals 3x minus 4. And then the g of x, which is going to be 3/2, and I'm going to open parentheses and do 3 divided by 2, and then close parentheses, x, and then minus 2. And you could graph the other form as well if you wanted to, and that would be written this way, parentheses 1/2, or 1 divided by 2, and then parentheses 3x minus 4. Those should give you, whoops, those should give you the exact same deal. So if you do y equals 3/2 x minus 2 or 1/2 times 3x minus 4, it should give you the same line. Okay, but anyway, let me graph these two and then we can compare the transformation. Okay, now notice that the red is not as steep as the blue, and the red is the g of x and the blue is the f of x. And we know this is a vertical shrink because the x-intercepts are still the same and the y-intercepts are different. In fact, the y-intercept is only half as great for the g of x than it is for the f of x. And we can look at the table to verify that. So for an input of 0, the output for the f of x was negative 4, and for the g of x is only negative 2. So that's what happens with a vertical shrink. The outputs are half of what they would be with the regular f of x function. Okay, so we just verified this g of x is the correct function for vertical shrink by a scale factor of 1/2.